In chemistry, let's look at the first question. Which of the following is an example of a mixture? Option A, common salt. Option B, blood. Option C, sand. And option D, washing soda. Mixture is formed when two or more substances physically intermingle or combine together. So mixture, they are not chemically combined, they are physically combined. Since they are physically combined, this can only be separated by a physical method. So let's go back to the options. Option A, we have common salt. Common salt is sodium chloride, sodium combining with chlorine. So this is what we call a pure compound. So we cannot separate this with a physical method. Option A is wrong. Option B is blood. We have the red blood cell, the white blood cell, plasma, and so on. So these components can be separated using a physical method. So the right answer is B. But let us also examine other options. We have sand. Sand is the combination of silicon and oxygen. Combination of two elements, silicon and oxygen. So this is a pure compound. Option D, we have washing soda. Washing soda is sodium trioxocarbonate 5 decahydrate. So this is a pure compound. It is not a mixture. So the correct option on the board is option B, blood. Option B, blood. So let's consider question number 2. Calculate the percentage by mass of nitrogen in calcium trioxonitrate 5. Given that the mass of calcium is 40, that of nitrogen is 14, and oxygen is 16. And here are the respective options. So let's go to the board. When it comes to percentage by mass of an element in a given compound, the first thing we must do is to write down the correct chemical formula of that compound. And the compound is calcium trioxonitrate 5. So calcium trioxonitrate 5 is Ca in parentheses NO3 2. Next thing to do is to calculate the molar mass of this compound. To calculate the molar mass, we add each of the respective elements present, then substitute with the masses given. We have Ca plus, in bracket, N plus, oxygen. Oxygen has 3 atoms. We are going to multiply this by the O. So we have this times 2. Alright, the next thing is to substitute the masses into this. Calcium is 40. We have 40 plus. Nitrogen is 14. 14 plus. Oxygen is 16. 16 times 3 times 2. Alright, so we have 40 plus, in bracket, 14 is 8 times 2. So we have here 40 plus 14 times 48 gives 62 times 2. So when you sum up, you are going to have 40 plus 124 is this 2, 4. If you add up, you are going to have 164 gram per mole. Therefore, the molar mass of calcium trioxonitrate 5 is equal to 164 gram per mole. The percentage by mass of nitrogen is equal to mass of nitrogen N divided by the molar mass of the compound. Molar mass times 100. Compound we have Ca in parentheses NO3 2. Alright, so percentage by mass of nitrogen in this compound is given as percentage by mass of nitrogen is equal to the mass of nitrogen, which is 14 times 2. 14 times 2. Take note of this. This 2 is affecting all the elements in this given compound in parentheses. So we are going to multiply the mass of the nitrogen by the subscript, the number of atoms. So since the mass of nitrogen was given as 14, we are going to multiply 14 by 2 to obtain 28. So we have percentage by mass of nitrogen is 14 times 2, all divided by the molar mass of the compound, which is 164 gram per mole. So 164 gram per mole times 100. Percentage by mass of nitrogen is equal to the numerator we obtain 14 times 2, which gives 28, divided by 164 times 100. And percentage by mass of nitrogen is equal to 17.1%. 17.1%. So let's go back to the option. In the option we have option C, 17.1% as the correct answer. So option C is the right answer. Question number 3. Question number 3. Moving from left to right across a period, the general rise in the first ionization energy can be attributed to the dash. Option A, decrease in nuclear charge. Option B, increase in nuclear charge. Option C, decrease in screening effect. Option D, increase in screening effect. Now we have to know the meaning of ionization energy. Ionization energy, this is the amount of energy required to remove one electron from a gaseous state. High ionization energy electron is very hard to remove, whereas low ionization energy electron is very easy to remove. Now what happened across the period? In the periodic table, if we move from the left hand side over to the right hand side, that is across the period, number of protons increases. More electrons are added to the same shell, to the same energy level. In doing so, atomic size will decrease. So since the atomic size is decreasing, the number of the nuclear charge is going to rise, is going to increase. So the correct option is option B, increase in the nuclear charge. The option is B, increase in nuclear charge. Let's move on to question number 4. Question number 4, how many unpaired electrons are there in the nitrogen subshell? Option A, 3, B, 2, C, 1, and D, none. Alright, the atomic number of nitrogen is 7. Therefore, it has 7 electrons. The symbol for nitrogen is capital letter N. Writing the electronic configuration of nitrogen using the SPDF notation, we have 1s2, 2s2, and 2p3. That is for the 7 electrons. Now, since the question is talking about nitrogen subshell, you are going to consider the most important subshell in this electronic configuration. So the most important subshell is basically the last shell, 2p subshell. 2p subshell. This 2p subshell has 3 orbitals called the p of x, p of y, and p of z. So we can actually provide this box for them. 1, 2, and 3. So this is the first orbital, px, second orbital, and the third orbital. In the first orbital, we can actually put one electron before moving to the next orbital. This is governed by what we call Hund's rule, which states that electrons occupy each orbital singly first before pairing takes place in a degenerate orbital. So by filling this, remember the last orbital is 2p3. So since you're having 2p3, there are 3 electrons. According to Hund's rule, we have 1 electron in the first orbital, another 1 electron in the second orbital, and 1 electron in the third orbital. Electrons occupy each orbital singly before pairing takes place in a degenerate orbital. So after adding these 3 electrons into the orbitals, none of these boxes or none of this orbital is paired. Take note of this. None of them is paired. None of them has more than 1 electron in them. Therefore, we can say that there are 3 unpaired electrons. So the correct option is option A, 3 unpaired electrons. When it becomes paired is when we have another electron with it like this. That's it. Question number 5. The stability of the noble gases is due to the fact that the dash, option A, have no electron in their outermost shell. Option B, have duplet or octet electron configuration. Option C, belong to group 0 of the periodic table. Option D, are volatile in nature. Alright, so the correct option, let's start with option A. Option A, no electron in their outermost shell. That is wrong. Group noble gases, the noble gases, they are basically the group O elements or the group 8 elements. So they have the complete electrons in their outermost shell or in the last shell. So option A is wrong. Option B, have duplet or octet electron configuration. That is the right option. The helium element, helium has 2 electrons in the K shell, which is the complete electron. The K shell has the maximum number of 2 electrons, while other shells has the maximum number of 8 electrons each. So helium has duplet electron configuration. Others like neon, argon, krypton, xenon, and so on has 8 electrons, which is octet electron configuration. So the correct option is option B. They have duplet or octet electron configuration. Let's look at the next question. Question number 6. Question number 6. The maximum number of electrons in the earth shell of an atom is option A, 2, B, 8, C, 18, and D, 32. The general formula for the maximum number of an electron in every shell or in a shell is given by the general formula 2n raised to the power of 2, where n is the principal quantum number. So at K shell, when drawing an electronic configuration of an element, we begin with the K shell. At K shell, n is equal to 1. At F shell, which is the required shell, from the question, n is equal to 2. So you can actually substitute this into the general formula. So we have 2 in parentheses, 2 raised to the power of 2. 2 raised to the power of 2 gives 4. And 2 times 4 is equal to 8. So the correct option is option B, 8. Question number 7. Elements in the same period in the periodic table have the same dash. Option A, number of shares. Option B, atomic number. Option C, chemical properties. Option D, physical properties. So the correct option on the board is option A, number of shares. Elements in the same period in the periodic table has the same number of shares. That is the reason when moving from left to right in the periodic table, more electrons will be added to the same share. That states that they are in the same period. So the correct option is option A. Question number 8. Consider the reaction above. The question is, the reaction above illustrates dash. Option A, alpha decay. Option B, artificial transmutation. Option C, nuclear fusion. And option D, nuclear fission. Let us consider the options again. Option A, alpha decay. So heavy elements emit, heavy unstable elements emit alpha decay. So option A is not the right option. Option B is artificial transmutation. Artificial transmutation is when one element changes to another element by bombardment. So this reaction is not in accordance to option B. Option B is not the right option. Option C, nuclear fusion. The term fusion means joining together, coming together, whereas fission means splitting. So when two or more light elements, unstable elements, comes together and energy is released, it is known as nuclear fusion. So the correct option is option C, nuclear fusion. Let's do question number 9. Permanent hardness of water can be removed by dash. Option A, filtration. Option B, addition of slaked lime. Option C, addition of caustic soda. And option D, boiling. So permanent hardness of water is caused by calcium sulfate, magnesium sulfate, calcium chloride, and magnesium chloride. So these salts cannot be removed by boiling. Let's examine the options. Option A, filtration. Filtration can only remove an insoluble solid. So hardness causing salts are dissolved. They are soluble. So option A is not the correct option. Option B, addition of slaked lime. Slaked lime is calcium hydroxide. And calcium hydroxide can only be used to remove temporary hardness of water, not permanent. So option B is wrong. Option C, addition of caustic soda. Adding caustic soda to, example, calcium salts will definitely remove the permanent hardness of water, because a white insoluble precipitate will be formed and the hardness will be removed. Okay, so the correct option is option C. Let us look at the equation for the reaction for this. But since this is JAMB, it doesn't require because of the time. If you add calcium sulfate with the option C, caustic soda, which is sodium hydroxide, this will yield calcium hydroxide plus sodium SO4. Alright, so this person is going to be removed from the equation, and insoluble precipitate is also going to be formed. So the correct option is option C. Now this option D, boiling only removes a temporary hardness of water, and not permanent hardness of water. So let's move on to the next question. Question number 10. Question number 10. What quantity of aluminium is deposited when a current of 10 ampere is passed through a solution of aluminium salt for 1,930 seconds. Given that the atomic mass of aluminium is 27, 1 Faraday is equivalent to 96500 coulomb per mole. Option A, 0.2 gram. Option B, 1.8 grams. Option C, 5.4 grams. And option D, 14.2 grams. So this is electrolysis in chemistry. To solve this question, we have to apply the Faraday's first law and second law of electrolysis. So let's bring out the parameters given on the board. From the question, we have the current of 10 ampere. Current I is equal to 10 ampere. Another thing on the board is the time given in 1930 seconds. So the time t is equal to 1930 seconds. According to Faraday's first law of electrolysis, which states that the mass of a substance liberated or deposited at an electrode during an electrolysis is directly proportional to the quantity of electricity that passes through the electrolyte. We have the formula as Q, which represents charge, is equal to current times time. So let's substitute the value. Q, charge, is equal to current is given as 10 amperes times time is given as 1930 seconds. So we are going to obtain 1930 coulomb. So that is the first thing we must determine. Now from the question we have what quantity of aluminium is deposited. To determine the quantity of aluminium deposited, we have to apply the Faraday's second law of electrolysis, which states that when the same quantity of electricity is passed through different electrolytes connected in series, the relative number of mole of the element liberated or deposited during an electrolysis is inversely proportional to the charges of the ion of each of these elements respectively. So from the law, we have quantity of electricity Q1 over M1 is equal to Q2 over M1, M2. So according to electrolysis or acidified in water using platinum electrode or graphite, let us determine the ionic equation for the aluminium salt given. Aluminium salt A3 plus 3 electrons would yield aluminium solid. So the charge for aluminium is +3. At this point, you are going to determine the quantity of electricity, which is Q1, using this charge. So Q1 is, now take note of these parameters. Q1 is the quantity of electricity from the ionic equation given, whereas Q2 is this quantity given from the question, quantity of electricity from the question given. M1 is the atomic mass of the element present, and whereas M2 is the expected mass of the element from the question. So Q1 is equal to the quantity of electricity from the ionic equation, and from the ionic equation, aluminium is +3, using the electrolysis of acidified in water, graphite or platinum electrode. So we have 3 times 1 Faraday. 1 Faraday is equal to 96500 coulomb per mole. So 96500. This will give 289,500 coulomb. So since Q1 is given as 289,500 coulomb, then Q2 is equals IT, and it was given to us as 19300 coulomb, where M1 is equal to the atomic mass of aluminium, which is 27.0, and M2 is the expected mass of the element in the question. So we are going to make M2 the subject of the formula from here. So M2 is equal to, making M2 the subject, M2 equals Q2 times M1. Q2 times M1 divided by Q1. So let's substitute the values. At this point, we are going to have Q2, and Q2 is given as 19300. 19300 times M1, and M1 on the board is 27, divided by Q1, and Q1 is given as 289500. So if you add this up, we are going to obtain
521.
Multiply this by this, we are going to obtain 521100 divided by 289500. So this divided by this, M2 is equal to 1.8 grams. So the correct answer is 1.8 grams.